All right. As soon as we see 1 and a Pythagorean identity, or something squared, we think Pythagorean identity. What is tangent squared x plus 1 equivalent to? Secant squared x. Cosine x, secant squared x equals secant x. Now, normally we write it in terms of sine and cosine. That's not an absolute must. For example, all right, if you notice that that side is already secant, you can rewrite them in terms of secant if you like. So in other words, this would become 1 over secant. Secant squared x over 1. What is one of the secants on the right and the secant in the denominator going to do to each other? Cancel out. And they're exactly the same. Right? Now, if you wanted to, you could certainly, when you got to here, so the cosine x secant squared x equals secant x. You can certainly write it all in terms of sine and cosine if you'd like. That'd be cosine x over 1 times 1 over cosine squared x equals 1 over cosine x. And then this time they're going to cancel, but the 1 over cosine x is found in the denominator. All you want is the two of them to be the same. That's it. Doesn't matter how they're the same as long as they're the same. Any issues with that? All right. Number 2, secant squared x cotangent x minus cotangent x equals tangent x. The first priority should be to factor out a GCF if one exists. On the left-hand side, what do both terms include? Cotangent x. Then Pythagorean identities once again. Secant squared x minus 1 is equivalent to tangent squared x. And again, you have choices. You can rewrite cotangent as 1 over tan. And realize once again with the square and the tangent x, they cancel out. We need tangent x equals tangent x. Or, like we said, you can write everything in terms of sine and cosine. So cotangent would be cosine over sine. Tangent squared would be sine squared over cosine squared. Alright? Sine squared and that sine will cancel out one of the sines. Cosine and cosine squared will cancel out one of those sines. I'm going to end up with sine x over cosine x, which is equal to tangent x. That, ladies and gentlemen, is a quotient identity. You do not need to rewrite that as tangent. If you leave it like that, that's perfectly fine. So your final answer should be two things that are either the same or an identity. And when I say an identity, it can be the Pythagorean identity rewritten. So in other words, if you have 1 minus cosine squared x equals sine squared x, that's fine. So they're either going to be equal to each other or an identity. Either one I'll take as your final answer. Good? All right. Sine cubed x plus sine x cosine squared x. Again, does a GCF exist? Yep. I'm going to pull it out. Sine x, sine squared plus cosine squared x. By Pythagorean identities, what is sine squared plus cosine squared equivalent to? 1. All right. If that situation occurs tomorrow, and you know that sine squared plus cosine squared is 1, and 1 times everything just stays the same, and you just want to cancel that out, that's fine for work as well. I'll leave it up to you. I cannot stress enough, ladies and gentlemen, this is a very small part. So if you just answer sine x is equal to sine x and think you're going to walk away, you're going to walk away a little disappointed. All right? You have to show your work. I will be in this room today after school for anybody looking for extra. All right? Everybody good with the GCF one? All right. Now's when things get a little tricky. Cotangent squared x minus cosine squared x equals cotangent squared x, all right, cosine squared x. When choosing between addition and subtraction and multiplication and division, I would simplify the addition and subtraction first. It's going to be a lot easier to rewrite that as that. So cotangent squared can be written as cosine squared over sine squared. Minus cosine squared x. If one of your terms has a denominator and one doesn't, I would rewrite it with a common denominator. So I would have to multiply the right by sine squared over x. Sine squared over x. Does anybody need to see what that step would look like drawn out and how it converts one to the other? Are you good from your study last year of rational expression? Okay. Now, if you do it that way, going back to the previous two problems, you now have a GCF. They both have cosine squared x in them. Yep. So I can pull that out. Now keep in mind what you're trying to do. You want part of it to be equal to what? Cotangent squared. Is that portion equal to cotangent squared? Yep. So I would just do that. Cross that out. And then look at 1 minus sine squared x. By Pythagorean identities, 1 minus sine squared x is cosine squared x. So rest assured there will be one with a GCF tomorrow. Good. Cosecant squared pi over 2 minus x. As soon as you see pi over 2 minus x, think cofunctions. Since it already has the co, you're going to drop it, and you're going to have secant squared x. And that's an identity, so you're done.
the other word we need to show?
If you get one with a pi over 2 minus x, if it works out like that, fine. You may get one like tomorrow. It may be like sine of pi over 2 minus x over sine of x equals cotangent x. You may get something like that. But that's the kind of the extent of it. So the idea is if you know that's cosine x right away, boom, that's usually a hint that it's going to be a short one. Right? Everybody else good with that idea? Again, I got pi over 2 minus x. The difference this time is it doesn't have the cos, so we're going to add it. So cotangent of x, secant x, equals cosecant x. Cotangent is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. What do the cosines do to each other over there? Cancel out. 1 over sine x equals 1 over sine x. So again, if you get one with the pi over 2 minus x, it should be a quick one. Good. As soon as you see negative, as long as it's not cosine or secant, you just pull the negative outside. So the cosecant of negative x is negative cosecant x. Secant of negative x is just secant of x. Cosine and secant go positive. Everything else, the negative comes out. Recall that, okay? From your even odd identities. That's the only thing you need to know about even odd identities. Alright, now, if you are faced with one like this, where you have a rational expression with secant and cosecant in it, I would rewrite it with the inverse. What I mean by that is this. Secant is the inverse of cosine, so I would move that to the top. Cosecant is the inverse of sine. Since it's on the top, I move it on the bottom. Negative sine over x. And cosine over sine is defined as cotangent. So again, there's going to be a mixture tomorrow of ones you can do really quick. And then there's going to be some that take you a little bit. Alright, but your even odd identities. Alright, remember that cosine and secant just go positive. You don't pull the negative out. Good? Sine x times 1 over cosine x equals sine x over cosine x, which by quotient identity is a tangent. Remember, this is the last quiz that you got to remember your identities. The next quiz and then the test, I'll give you the reference sheet that has all the identities on it. Good? Alright. secant squared x, tangent squared x, plus secant squared x equals secant to the fourth x. We go back to a GCF. Secant squared x, tangent squared x plus 1. Tangent squared x plus 1 is secant squared x. And when I take something squared times something squared, I have something to the fourth. I just thought it came out too pretty. You know what I mean? Just by mere circumstance, I'm like, no, it can't be. That's what happens when you steal stuff off the internet. You don't really look at it till and you go, you know what? Maybe I should look at stuff more. That was 10, right? I just looked at. Came out too pretty. Alright. That's the thing. Alright, so number 10 would be something that's extra credit because you have to rewrite cosecant as 1 over sine. You have to rewrite secant as 1 over cosine over sine x plus cosine x. Alright. This would become cosine x plus sine x over cosine x sine x. Sine x plus cosine x. Again, this is going to be extra credit tomorrow, so. Alright, this becomes a complex rational expression that we'll do plenty with when we start doing double and half angle identities. Alright, so that becomes a division. I usually rewrite these as a division problem. Hello. I am going over identities. Yeah, I'll step outside. Hold on. What on this side?
Oh, yeah. Alrighty. Bingo, bingo, bingo. So basically what you're doing in this is when you rewrite cosecant and secant in terms of sine and cosine, your numerator becomes a fraction. This step, you're finding a common denominator. So going from here to there, you find a common denominator, and then it becomes your complex fraction. And then with this, these two cancel out.
And they're all ready to go? I got it. Okay. And do you want me to label the two that are broken? Okay. Alright. Alright, thanks, fellas. And the 1 over cosine is the secant.
Yes.
And the 1 over the sine is the
no, you know what it is? You substitute 1 for the identity. That's what it was.
Okay.
So you kind of do like a reverse identity for this one. So you're actually putting in sine squared x plus cosine squared x in for 1. So you have to substitute it. And then since you have a binomial in your numerator, you can break up the fraction. key.
There you go. And that's why it's expressed.
Oh, it's
Because you have to reverse what we've been doing, so that's why. Alright? Everybody good? Alright. So that gets us through 10. 11 through 14. Ah. Alright. So, again, has a denominator, doesn't have a denominator. Alright? So basically, I'm going to multiply that by 1 minus sine squared x, alright, over 1 minus sine squared x, plus cosine squared x, 1 minus sine x, over 1 minus sine squared x. Let me write it down first, and then we'll walk it through it. So what I'm kind of doing is I'm combining steps. In other words, remember from 5.1, we got to find a common denominator. So rather than just multiply the 1 times the 1 plus sine x, I recognize that by using the conjugate, I'd end up with 1 minus sine squared x. Make sense? So if you see 1 plus or 1 minus something right away, I would multiply both sides by the conjugate and the result. That way you can consolidate steps. Alright? The result would be cosine squared x. Alright? Over 1 minus sine squared x.
the left side is 1 plus, and then the right becomes cosine squared x times 1 minus sine x over cosine squared x. If you get again the denominator,
Okay.
the cosine squared x cancels out.
Right. Okay.
So you have 1.
So this becomes 1.
Yeah. And it's minus subtraction, sign addition. Like the main problem itself.
Up here.
Yeah.
That's right.
Yeah.
Alright. And again, these are exactly the same, so they're also going to cancel out. So you have 1 minus sine x. The 1 minus 1 plus sine x. The 1 minus 1, of course, does what? Cancels out, leaves you with sine x equals sine x. There we go. But again, if you see 1 plus or 1 minus, I go right to the conjugate to get to 1 minus sine squared, so therefore you have Pythagorean identity. What, tiki tiki tiki? Well, it does annoy you enough to pick it up. I will tell you that. Alright. So basically, ladies and gentlemen, 12 looks a lot harder than it is. When you have a monomial in your denominator, just break it down. So take the two parts of your numerator, which would be sine x, cosine x, minus cosine x over cosine x, minus 1. Alright, now I did, and I don't know if I shared it with you guys, that should have been a plus. I apologize, I posted in Google Classroom. That should have been a plus. Whenever I have the same expression, that becomes 1. So this becomes sine x over cosine x minus 1 plus 1. What does the minus 1 plus 1 do to each other? Cancel out. So now I got sine x over cosine x equals tangent x, which is a quotient identity. You can leave it like that, or you can rewrite sine x over cosine x as tangent x. So whenever you have a monomial, I would break it down. Alright. Next up, we have number 13. Alright. I'm going to rewrite 13 with a common denominator. So that becomes 1 over tangent x plus tangent squared x over tangent x. 1 plus tangent squared x is secant squared x. Alright, I have a simplified expression. So in other words, I can't break it down, I can't do anything unlike the last one. So I would rewrite that in the numerator with the reciprocal. The reciprocal of tangent would be cotangent. So that would be secant squared x times cotangent x. Then I would rewrite everything in terms of sine and cosine. That becomes 1 over cosine squared x times cosine x over sine x. Cosine x over cosine squared x, that's going to disappear, that's going to cancel. I'm going to have 1 over cosine x sine x. Again, it's a monomial, so I break it down. That'd be 1 over cosine x times 1 over sine x. 1 over cosine x is secant x. 1 over sine x is cosecant x. Boom. Good. All right. That leaves us with 14, 15, and 16, correct? Tangent x over secant squared x equals sine x cosine x. Monomial, move it up to the top, rewrite using reciprocals. Tangent x cosine squared x. Tangent x using quotient identities, sine x cosine x times cosine squared x over 1. Cosine squared x over cosine x cancels that, gets rid of that. And I got sine x times cosine x. Alright, 15. Cosecant x over 1 minus cosecant squared x. Cosecant x over cotangent squared x. Again, monomial, so I'd move it to the top. Cosecant x times tangent squared x. The one thing I will tell you is because this is flipped, Instead of positive, it's negative. So that's where the negative comes from. Cosecant x is 1 over sine x. Negative tangent squared x would be negative sine squared x over cosine squared x. Alright? Negative times a positive is negative. Sine squared over sine is just sine x over cosine squared x. Whenever your denominator has a degree of 2 and your numerator doesn't, rewrite it, break it down, and make one of your numerators 1. Sine over cosine is tangent, so that's negative tangent x. 1 over cosine is secant, so that's secant x. That was 15. Good? And then the last one before you scoot, 16, sine x over 1 minus cosine x. This should have been a plus, by the way. Again, I put it in Google Classroom. I apologize. I would multiply that by the conjugate, which would be 1 plus cosine x, 1 plus cosine x. You're going to have sine x, 1 plus cosine x, over 1 minus cosine squared x. You can distribute if you want, but it's not necessary, because 1 minus cosine squared x is sine squared x. So this becomes sine x over sine squared x times 1 plus cosine x. The sine over sine squared cancels that, gets rid of the 2. So I got 1 plus cosine x over sine x. Again, I have a binomial over monomial, so I break it down. One over sine x is cosecant x. Cosine over sine is cotangent.